The reason why the Anthropocene can be dated to such a specific time is because go back to your lessons on the way archaeology is done. We talked about dating. We talked about events that signal a rapid transformation from one time period to the next, and talked about things like terminus antequem, time before which, terminus adquem, time to which, a specific moment in time, and terminus postquem, time after which things occurred. So if you find an object in a geological stratum that has a dinosaurs in it, then you know it must be from the Mesozoic period, probably. Now, this is important because 1945, and in fact July 16th, 1945, was a moment in time when something changed that will always be able to be identified by geologists in the future. And that was atmospheric testing of nuclear weapons. Before that moment in time, the world had never seen a nuclear weapon. Never, ever, ever. Never. There is no evidence for any nuclear explosion in geology before that date. But the atmospheric explosion that took place in New Mexico is now on every place on Earth. It has gone into the atmosphere and it has settled down, and it will be observable by geologists millions of years into the future, which means that they will, if you dig down, you will come to our layer that we're standing on right now, which will be buried below the ground in the future, and they will find, okay, here's nuclear, and they'll come to this point, and if you dig below 1945 and you go earlier, there will be no signature of atmospheric nuclear radiation. So, because of this, that's a good time period to sort of draw the line between the Holocene, which we were looking at last chapter, and a new epoch, the Anthropocene. And it's also a good time because that is maybe not the beginning of industrialization, but it's when we really start to see the impact of industrialization on the world. We start removing mountains from the landscape to quarry them, and digging big holes and terraforming our planet, and ramping up production and polluting things, and pumping out greenhouse gases which change the environment. Now, all of these things we've talked about before, changing the topography and the geology, changing the environment, taking forests being reduced. These are all things that our ancestors had to cope with as well, but they were natural phenomenon in the past. Now, you and me, we are going to have to face a lot of different factors that humans are doing. So our own choices have created such a profound impact on our environment that this is the new challenges that we're going to have to face. And so things like climate change, population growth, and even technology are going to be factors that will help us to identify this epoch in the future, if that's decided to be the case by scientists. So let's talk about climate change. This is a really big one. This is politically controversial, I understand, but it is absolutely, unequivocally not controversial in science at all. It is, we understand the data. It is incontrovertible, irrefutable data. They are. And the degree to which human behavior is causing this is debatable amongst science, but there is really no doubt that the humans are at very least contributing to it. global warming. Data like, for instance, the glaciers, like the one on Mount Kilimanjaro, has reduced by 85% in the past 100 years. Polar ice caps have increased sea levels by 5 inches in the past 100 years. These are all measurable changes. So we can see that not just is climate changing, and there's a graph in your book that shows that although fluctuations occurred, the general trend is that on that sort of fluctuating thing, it's increasing through time in the past 50 years, 100 years, something like that. There is very strong evidence that humans are causing or at least accelerating the warming of the planet. And the reason why we know this is because, first of all, there's very strong correlations with industrialization and this change. There's a reason why we were sort of flatlined for so long, and then we start pumping out industrial gases, things like CO2, that I'll come back to in a second. And that correlates to this increase in global temperature. And these are averages. This is not weather. This is not what you look out the window and you think it's going to be cloudy or sunny or rainy today. These are averages, and they're going to have local effects in different ways. They're going to change currents and tides and weather patterns. So global warming just means that this is a general trend, but it's going to have a range of effects. Things like more energy being put into storms, and so you're going to have larger and more powerful hurricanes or tornadoes. Now, how do we know that this correlation is causal? Well, because we understand the mechanism. The way I like to say it is, I know that we are causing climate change because I know how to bake a cake. All you have to do is put in the right ingredients at the right temperature, and you're going to have a cake. And we can debate as to whether I mixed up the batter well enough and it was fluffy and has air in it and it's going to puff up, or it's going to be more compact and more solid cake. But it's going to be a cake, right? And so that margin of error is it a really dense cake or a really light and fluffy cake? It's somewhere in between these extremes, but we know that it will be cake. And that's really the basis of the debate in science. Isn't whether humans are changing the climate. It's just, is it the worst case scenario or is it the best case scenario? And the best case scenario doesn't look particularly good. Now, the reason why this is just a recipe is because we know the mechanisms. Once again, uniformitarianism is the principle that we can go back to look at, to say you can look at what a greenhouse does. And you can measure the heat that gets trapped when it comes through a greenhouse. It goes into the greenhouse and then it bounces around inside. And we have a greenhouse on our planet. We have greenhouse gases that surround our atmosphere, and the sun's energy comes in and it gets trapped in there. It bounces around and heats up and keeps us nice and cozy and warm. We could not survive without greenhouse gases. We could not survive without the greenhouse effect. Otherwise, all the sun's energy would go right past us and not stay on Earth and just go right out into the cosmos and heat up some other object out there. We benefit from greenhouse gases, but there's too much of a good thing. When you increase those, it increases the amount of energy that's being stored or trapped inside the Earth's atmosphere. And then this compounds factors, like, for instance, light color reflects light. So white snow reflects light back out into the atmosphere, past the greenhouse gases. But if the snow melts, or the glaciers melt, or the ice caps melt, you no longer have that white. In fact, you have very dark colors like the dark sea in the Arctic, or the Earth, which is also darker colored. And then that absorbs the light and doesn't allow it to be reflected. So once you start down this road of global warming, of climate change in that direction, it starts to get more and more intense. And we are at a point where it is starting to ramp up and it's going to get out of control. So we know not just the correlation between the buildup of things like carbon dioxide and temperature increases, we know the mechanism by which this happens. So it's not just correlation, it's a clear causation. We know that it's happening. There's no scientific controversy about it. Not only that, but it's not just that, okay, uniformitarianism is you're not able to go back in time and see maybe maybe fluctuations in temperature are happening all the time. Yes, they are. But we actually have a very good understanding of the paleoclimate, of the past environments, because of things like ice cores. Climate scientists go to places like Greenland, and they will core down a very, like a tube. They will take a drill core out of the ice sheet, and these go back almost 1 million years. And what happens in ice? Well, what happens in water? What if you take a straw and you start blowing into it? You get bubbles, right? Well, ice has bubbles too. And just in the same way that stratification of geology takes place, these ice caps and glaciers in Greenland, they go down in chronological order, just like geology does. And so when you take that core, you're going back in time. And those air bubbles that are trapped in ice have old air in them. And you can pop those and you can analyze them and you can see what is in that air. So it's not just that we have to guess about past environments. We actually have ways that we can have proxy data to give us a direct evidence for what past environments were like, going back at this point more than 800,000 years. And this clearly shows that it's consistent with the Earth warming right now, and that the warming is a result of greenhouse gases into the atmosphere. And this has consequences, of course. Now, for you and me, we live in America, and we are some of the biggest producers of greenhouse gases. So the things that are changing to the planet, we're doing. Do you think that the people in the Maldives Islands are pumping out as much greenhouse gases as you and I are? Of course they aren't. But the Maldives are islands. It's an atoll, an archipelago of very low-lying islands in the Indian Ocean. And with sea levels rising, their country is going to be gone. And they're suing the United States, and they have every right to do so, because they didn't cause this problem, but it's affecting them first. And so the consequences, and this is where it's difficult for humans to sort of get to grips with what's happening, is it might not happen to you right away. And we think, why should we even care? Well, it will eventually come back to us too. But the countries that have the most output of greenhouse gases tend to be the ones that are going to be the least affected by it. And so places that have drought, places that have fluctuating weather patterns already, places with actually the opposite of drought, flooding, and coastal regions that have storms or standing water for malaria. All of these things are going to be affected by climate change, and the hardest hit and the first hit are going to be the ones that have the least to do with creating this problem and are the poorest and the most vulnerable to its effects. So we are killing poor people by our behaviors. We're also climate change and our behaviors are creating population increases, and we've talked a bit about climate change, but we're also destroying the natural environment. Biodiversity is really in peril. We're destroying habitats through deforestation, and climate change and expansion of urban areas. We're concreting forests, basically. And what happens when you destroy an animal's habitat? Well, they don't have any place to live and they die. But what you're doing is you're upsetting a balance. We've seen throughout this course that things evolve together. They don't evolve on their own. They don't adapt on their own. A predator needs prey. Prey needs plants. And parasites need bodies. And we need all of this. So when you have one or two elements taken out of an ecosystem, that ecosystem then starts to break down. It's no longer a system. And you have maybe some things like diseases like West Nile virus, Lyme disease, malaria start to take off because you have fewer bats or you have fewer birds because they don't have any place to live. And so in the coming decades, species diversity is expected to reduce by 14%. And this will affect our health and our well-being as well. Also, population growth is affecting and people living together in large population agglomerations, 20, 30, 40 million people all together living on top of one another, are accelerating diseases that are starting to emerge. Some are because we're coming in closer contact with things that we never really came into contact with before. Things like Ebola and severe respiratory syndromes like SARS. Coronavirus is one of these acute respiratory syndromes. And this is the result of us living in very close proximity to one another, and then also those big populations living in proximity to other animals and parasites that we never really came in contact with. And we can see very easily how quickly these things can spread when we have no immunity to them. Our immune systems have never had to deal with these before, so they don't know what's hitting them. And it spreads very easily because we're in such close quarters and we're so connected by the way we survive today. Also, drug resistance. We have been medicating ourselves out of every problem that we've come across, and that has led parasites, bacteria, things like that to evolve in response to our threats against them. And so you now have things like drug resistance bacteria. Tuberculosis and malaria are adapting. We have malaria medications that prevents malaria, but the ones that we used 150 years ago don't work anymore. You can't, in fact, just an anecdote, tonic water was invented because quinine tastes terrible. And so tonic water was invented, so a little spoonful of sugar in your medicine, malaria medicine. And but if you drink tonic water today and expect to be immune from malaria, you're going to be disappointed because every malaria virus on Earth isn't affected by pure quinine anymore, and we need different types of medications today. They've adapted, they've evolved in response to our attempts to thwart them. So these are all pretty bleak things, right? But at the same time, our humans have adapted in a way that has led to some positive things as well. We now, Americans, live 30 years longer than we did in 1900, on average. That's great. We all want to live long and healthy lives. And medicine has made us healthier, or at least it's allowed us to be healthier. And this longevity is really great. But this small snippet of a glimmer of hope comes with downsides as well, because that means with people living longer, population increases, and you then have new types of problems. Cancer is increasing, possibly because people live longer. People might have died of other conditions earlier, and only cancer onsets at later in life for some people. So you see some conditions that we just were rare because people never got that old in the past, or it was rare to. So rates of things like osteoporosis, heart disease, cancers have all increased, probably as a consequence of us living longer in general. So you got to take the bad with the good, right? If we're going to live longer, you also have to expect that something eventually is going to kill us. Also, our longevity is partly due to the fact that we have better medicine, but we also have better nutrition. And we're taller than we were 100 years ago. We talked a little bit about how when agriculture came in, humans shrank because we were using our bodies differently. So we didn't have the musculature and the bone structure that our hunting and gathering forebears had. And then we plateaued at this sort of much shorter level for many years as people were agriculturalists. But in the last 100 years or so, we've become about, on average, 2 inches taller than we were 100 years ago. But, and that's largely because of nutritional improvements. We talked about this a little bit in a previous chapter, the secular curve. But we're also about 50 pounds heavier than we were in 100 years ago or so. And this is because of our dietary choices. High in saturated fats and sugars, they're abundant, easy to get to, and interestingly, perhaps a little depressingly, food that has high quantities of protein and fiber, which are expensive, are less accessible by poorer people. And fats and sugars are usually less expensive and more available to people that are in poverty. And so there's actually a relationship between things like obesity and socioeconomic status. And obesity is a real problem. In fact, this dietary shift and resulting increase in obesity is what we call the nutrition transition. And along with the general decline in physical activity, as we've seen over the past several thousand years, this has led to the worldwide epidemic in obesity. Why is it worldwide? Well, because we've exported this westernized diet to